Hello everyone. Today I will present you something about OpenTelemetry. I will tell you about OpenTelemetry, how it works, how to set up it in .NET, and you will hear a lot of stuff from my experience, a lot of but sorry. Sorry for that. But before I start, I want to present myself. My name is Alex, and I'm a software engineer in IBM. I'm working here already for 2 years, and I'm working in United Platform team on target process. We are working on different stuff like monolith, search service, snapshot, event subsystems, and all other stuff you don't need to think about. Fun fact, our sub-team calls USB, which stands for United Sexy Boys, but I think it's good to mention. Also, I worked as a DevOps engineer for more than 5 years, and maybe that's why I like to work in platform teams and work on some platform stuff. And there is an agenda for today. First, we will talk about the main problem which I faced with and why I decided to dive deeper into OpenTelemetry. Next, we will talk about OpenTelemetry in general, how it works, how it looks like, what it is, and about traces in general. Also, we will talk about .NET implementation of traces and some filtering approaches for tracing. In the end, we will have some time for a Q&A session, and you will be able to ask some question to me. And let's begin with the main problem which I faced with. There is a message from the Slack from one of our SRE engineer. He wrote that due to the fact that we started to write a lot of telemetry in our Elasticsearch, and back then we used Elasticsearch for our logs and traces, it started to crash. And that's why he decided to decrease retention period. For logs it was 17 days, for traces 3 days, and for spans 2 days. And from one perspective, we can say that it's okay, but from another one, just imagine that we have an issue which is reproducible, but reproducible once per 5 days, 6 days, whatever, and telemetry makes no sense here. So after that message, I decided to dive deeper into OpenTelemetry and try to understand how it works. And let's begin our journey with like general knowledge about OpenTelemetry, but before we begin, I will ask you a couple of questions. First, please raise your hand if you don't know what does it mean OpenTelemetry and what it serves about. Okay, then I will touch it briefly. Now raise your hand if you set up OpenTelemetry at least in one service in your life. Okay, and raise your hand if you set up filtering, sampling, processors, some custom stuff on top of OpenSearch or OpenTelemetry, sorry, in your service. Okay, nice. So then we will go briefly about OpenTelemetry, and in a couple of words, what is OpenTelemetry? Before OpenTelemetry, we used proprietary libraries for different stuff, different services. For example, for New Relic, for New Relic, Datadog, and other things. And if you needed, for example, to switch a vendor, you needed to change the library, to rewrite the code in your code base, etc. Maybe now it's not so significant because we have AI. We can say, hey, AI, please switch it from New Relic to Datadog, and it will work. But that days, it was important. And that's why OpenTelemetry was created. OpenTelemetry, it's like framework which was created to provide some measurements which we want to know about our service, what's going on in our service, and send it in a common way. The main idea here that's OpenTelemetry covers messaging between client and backend. It doesn't tell you how to implement OpenTelemetry backend. It's all about how to send span, trace, whatever, metric, whatever, and how it must look like. So, and here you can see different libraries, not different libraries, but different things, which is OpenTelemetry cover for different languages. And I compared it with the same list 2 years, which was 2 years ago, and as I understood, a couple of new languages was added. For example, Kotlin was added. Rust was switched from alpha to beta, and we have now profiler in Java. But what does it mean? There's traces, metrics, logs, etc. In OpenTelemetry, we have different signals. Signals, it's something we want to get, we want to know about about our software, about our service. First, it's traces. Actually, it's a path. We can see the path, what's going our request. For example, from service A to service X, whatever. Metric, it's something, some measurements which we can get like in this particular moment. And logs, it's some events which happens in our application, and we can gather it with OpenTelemetry as well. Also, we have baggage. I don't know why guys from OpenTelemetry decided to add this baggage to signals, but from my perspective, it's not a signal. But baggage, it's something what you can take at the start, in the beginning of the request. For example, you have some site, and user, I don't know, clicked on some button. And on the first service, we are able to get this username who made an action. But with baggage, we will be able to propagate this user ID username to another services, and they will show it. We will see this data in other services as well. Also, guys from OpenTelemetry said that they will add profilers in the nearest future, so we will be able even profile our code with OpenTelemetry. But today I want to focus only on traces, and if you want, for example, something about other signals, you can tell me. Maybe next time I will present something else. And let's start with spans and traces. These two names I hear, I think you're familiar with these two things, but I hear that people mix them up, and that's why I decided to add one more time, just to brush up it in our heads. Just imagine that we go to a restaurant. We decided we want to buy something in the restaurant. For example, we want to buy a burger. I don't know why, because I like burgers. And we choose the appropriate burger. We ask waiter for appropriate burger. Waiter go to a kitchen, and on the kitchen cook, prepare this meal for us. Then we get the meal, eat it, pay for it, and go away. Just here, span, it's a concrete action. For example, I made an order, span. Cooked a burger, span. Waiter got a payment from us, span. But trace, it's the whole history of our what we ate, how we ate, when we got a burger, etc., etc. The whole history of this being in this restaurant. Now we know the difference, and let's take a look on the spans in the wild, how it looks like for programmers. And it looks like that. It's just a structured log. nothing special. We have names here, context here, start date, end date, attributes, and events. If we're talking about attributes, it's something which what belongs to this particular span. For example, we triggered HTTP endpoint. We can put this endpoint into attributes. Whatever, it can be correlation ID, user ID, whatever you want. If we're talking about events, it's something, just think about that as about logs in your span. For example, you want to mention a specific protocol which was used during during working our application, whatever, I don't know, some specifics of validation forms, whatever. We can put any information we need here in events. Also, we have, each span has context which contains trace ID and span ID. Trace ID, it's something unique across the whole request, but span ID is unique for this particular action, as we told already. And also we have parent ID in our JSON, and this parent ID allows us to make this inheritance. We can, with this parent ID, we can say that this particular span was created within this span. On the left side, you see that parent root span has no parent ID, and it means that it's the root span. It was created as the first one. And then on the left side, you can see the, actually for you it's right side. On the right side, you can see that we have an ID in parent ID, and it's totally the same ID as which we have in span ID on the left side. It means that right span is a child for left one. But how can we understand that this concrete span is the latest one? That's this trace was ended. Actually, you have no ability to do that. In most of the cases, your OpenTelemetry backend just waits for 30 seconds, whatever, maybe a minute, and every single span which was like accumulated during this period of time will be written. If you will send additional spans, they won't be a part of your trace anymore after that period. And in the end, when we set up all these spans, etc., you will see this beautiful picture. On this beautiful picture, you see that we have different requests through different services. We see how much time it took to make some requests to MySQL, to OpenSearch, etc. And looks amazing, right? Now, we can talk about, we know how it looks like, how it looks in the protocol, on the protocol side, but how it looks in .NET, how it was implemented. Actually, in .NET, we have three iterations, in evolution of tracing. And the first thing which was created by Microsoft, it's event source. Event source was created just to gather events to event tracing for Windows. You maybe can find it in some legacy projects. Honestly, I haven't seen it in my life at all, but maybe you will see it. But the main idea here that it was highly coupled on Windows and it didn't survive after migration to .NET Core. And with .NET Core, Microsoft decided to create another source for our traces. It's diagnostic source. It was cross-platform. We was able to create events everywhere, in every single things we want. I mean, like platform we want. It supported structural data as well. And if, for example, previous predecessor was able to store, for example, int, string, whatever, but now we can store the whole object in our diagnostic source. And it looked good, quite good, but we had only one issue. One issue which, one thing which we see in OpenTelemetry what we can't implement in diagnostic source. And it was inheritance. We wasn't able to create inherit spans to show that this particular span created another ones. So, and that's why Microsoft decided to create activity source. It's actual standard, and I suppose you will see it in current implementations. Here, we are able to create hierarchy for our spans. It works well. It has all abilities which OpenTelemetry has, but it has a different naming. Due to the fact that Microsoft decided to create this library in the same time when OpenTelemetry protocol was created, and they moved like together, they started to use different naming convention. For example, they call span activity, or tracer for them it's activity source. So just keep in mind that sometimes I can say activity and it means span. That's it. Just we need to keep it on our mind. But how to implement it in our code, actually? How to add this instrumentation on our code? Firstly, we need to create a separate class for that. I called it instrumentation because it's instrumentation. I don't know why. So it has activity source, which we will add to our DI container as a singleton. And there is a thing. OpenTelemetry developers tells us that it would be better if we will use one activity source per service. Actually, you can create 2, 3, whatever you want, but they say, guys, please create only one and use only one. Then we will be able to add this didn't fix it slide, but whatever. Here must be this instrumentation class, and execute activity from that instrumentation class with like create an activity with the method start activity, or and add tags, add events, etc. as we want. Here also one more thing. Also, guys from OpenTelemetry said you don't need to collect data about things which you don't interested in. For example, I don't care how much time I will spend on that creation of this list. I don't care, actually. And that's why I decided to create span after that. And please stick to that approach. Then you will see, we can configure everything in our DI container. In add source method, we provide the same value which you can see in our instrumentation class. I can show you here the same source name. And actually, just imagine that we have a library which implemented use of activity sources, but they have no libraries for instrumentation. We can just add the name here in add source method and connect it to our OpenTelemetry. That's it. So it works so simple. But yeah, now about nesting. I said that it's important feature which was added in activity source, etc. But how to understand how our code, our system diagnostics understand that one particular activity is a parent of another one. Actually, you have two options. First one, you can create first parent activity, and then inside of using of the parent, you can create a child one. And the .NET library will automatically understand that one of them is a child of another one. Or you can do it manually if you want, but I don't think that you want actually. So I told you about instrumentation, about how to set up it, but and if we're talking about HTTP request, as I said, that it will be instrumented automatically. Our system diagnostic will add headers to our HTTP requests, etc. But What can we do with asynchronous communication? How can we send this information about span, trace ID, whatever, just to prolong our span in asynchronous communication? Actually, for that, we have special thing, which calls trace parent. Trace parent, it's like, I don't know, structure, let it be structure, which consists version, actually it's only zeros here, trace ID, span ID, and some flags. They added this flags as a bit mask for future things, but for now you can just write here if it was sampled or not. So it will be 0 or 1. And you can get this value from activity class, from current ID property. Then you will get it, you will be able to store it to database, you will be able to store it in headers in your RabbitMQ, for example, for RabbitMQ, whatever you want. You can even send it via SMS and restore it later. But how to restore it? We have a special thing for that, special class activity context, which has a method tryParse, which can parse this trace parent, and we will be able to add this trace parent to our activity. So, but we don't need to do everything by our hands. In most of the cases, we have communities libraries, which allows us to add this instrumentation automatically. For example, we have Get packages for our HTTP instrumentation, SQL server instrumentation, EF core instrumentation, whatever. Also, in most of the cases, it will calls like OpenTelemetry instrumentation something. But if you can't find something here, maybe maintainer decided to create another package, which, for example, for npgsql, it calls npgsql OpenTelemetry. Why? I don't know. And also we have like a magic wand, which allows us to instrument almost all other libraries, which calls auto-instrumentation. And we can add this auto-instrumentation with this OpenTelemetry auto-instrumentation library. Actually, previously you needed to use to execute some bash code to add something to your Docker file, but for now it's not necessary. For OpenTelemetry auto-instrumentations, we have actually two ways. First, and success way, we have already some kind of old instrumentation in this library, for example, in EF core, and our OpenTelemetry auto-instrumentation library just subscribe on this, like another source, and instrument it. And the second thing, profiler. Profiler just subscribes to JIT compilation events, just add some additional code into our library, and send it to our CLR. So, and after that, every single library in which we don't have instrumentation will be instrumented, as I thought, actually, but no. They have only a list of libraries which is supported, and you can't just instrument any libraries you want with that stuff. Whew, finally, we created our service. We know how it works, how OpenTelemetry works now, and we implemented it in our service. And then we came back to our problem. Yeah, I decided not to place the same message here because you already seen it, but the main idea here that we started to write too many traces. What can we do with that? The first thing which you can came in your mind is filtering. Easy. And to understand how to filter our spans, we need to understand how the spans life. Firstly, we have span creation. Then we're populating the span with some data, text, events, whatever, And then we export it to our OpenTelemetry backend, Datadog or New Relic or I don't know, other stuff. And we have two options. First, head-based sampling, which will filter everything on the span creation. And the second one, tail-based sampling, which works before exporting our trace. Let's go one by one. Head-based sampling. It's the cheapest approach, but the main issue in this approach that you are not able to filter your span but by some data. For example, by I don't know, text inside, by I don't know, some errors, etc. It's not possible because you just created the span and you need to understand if we need to drop it or not. In most of the cases, it uses just for sampling, to add some additional sampling. For example, to store 10% of our traces, 1% of our traces, whatever. And here, when I said that, I want to say you that in most of the cases, 1% of your traces is enough. You can drop everything you want, except for this percent. Why? Because traces can get us the next data. First, it's the latency, and the typical path of our request. And we don't need to store actually all traces to get the same information at all. And let's take a look on these two slides. Actually, I created it a couple of years ago, but it's also relevant. Here, you see latency distribution for the same service on the same environment, like totally the same services, but with different settings of sampling. For the first look, it looks different, right? But let's take a look on the 100 milliseconds part. I see some patterns here. I don't know about you. Or, for example, here. Can you see something similar? And here, I want to say that if you will take a look on the whole picture, you will understand that it's totally the same graphs, but with different zoom. Here, this zoom is like lower. Here, we have higher zoom, etc. And you don't need to store all traces. You can get rid of most of them, and you will lose nothing. But you need to set up the zoom in an appropriate way for your service, of course. And you can do it by trial and error. We have no other options. About filtering, let's go fast via that. First, some instrumentation libraries has their ability to filter some requests. For example, with that filter in ASP.NET Core instrumentation, we are able to filter some /metrics endpoint, /health endpoint, etc., like all this garbage from our backend. Also, we are able to create our own sampler. And as you can see, there's one of the implementation which we have in our services. Here we have parent-based sampler, which has inside trace ID ratio based sampler. And it's two samplers which you can find in the library by default. But why we decided to do that this way? We decided to not to put just trace ID ratio based sampler, but decided to wrap up it in parent-based sampler. Just imagine that we won't do that. What will be? You will see that some tracers in which you can see some service from time to time. In some traces you can see that this service do something, but in some traces it's not. Because you won't be respectful for a parent decision of another service. But parent-based sampler will take a look on your parent span, check if it was dropped or not, and then it will decide if we need to preserve it or drop it. So also, I wrote here not simply decision record only instead of drop, but I will tell you later why I decided to do that. And actually, this slide about parent-based sampler is important, but let's go next. Tail-based sampling. We're almost in the end, guys. Almost in the end. Tail-based sampling. In this way, we can sample our data, for example, by errors. We can sample by duration. We can sample by any characteristic we want, and add some required for us things. For example, here one of the examples of tail-based sampler, which we have, and actually it just stores all activities with errors and duration. And why we decided to do it this way? First, we need this activity, this information, because it's the most interesting part that we can see that something was like executed too much time, or we had an error somewhere. But also, do you remember that I mentioned that we don't drop our spans at the start, but write it as record only? If we drop our spans in head-based sampling, we won't be able to sample it here, just to find it here. It will be dropped completely. But if we will write, use here record only, I mean in this part, we will be able to sample it in tail-based sampler. So, and here, if the activity is not recorded, but it has an error and executed too much time, we just mark it as recorded, and it will be sent in our OpenTelemetry backend. So there is then an example of the instrumentation. We can just use add processor here. And here, one more interesting part. You can see two DI container pipelines here. In first, I added processor as the second thing, and here I added it in the end. Honestly, I spent for that maybe a day just to understand why it doesn't work. I added this processor this way, actually, and but it didn't work. I tried to understand why. I thought that it's a problem on the OpenTelemetry side. I spent a lot of time, but then I realized that exporter is has the same base class as processor. It derives from base processor as well. So what I want to say, Q here is important. Don't repeat my mistakes, please. Don't spend a lot of time on that. And this is actually the results. After this implementation, after I started to instrument it in the right way, our service from top 10 went to top 30, top 40 by count of traces. We didn't lose a lot of information, and actually Elasticsearch started to work in the correct way. But for you guys, it can cost, for example, additional money if you won't sample your traces in the appropriate way. And this is almost the latest slide. A couple of weeks ago, one of the SRE engineers came to me and said, hey, I saw that I see the service and I like how your traces was implemented. Can I use it as an example to migrate it to another backend? And for me, it's really important to hear that I did a good job. And after that presentation, I want I hope that you will go to work, revise your traces OpenTelemetry implementation, and make it as best as it possible. Actually, that's it. Thank you. It's time for Q&A.